Now that students have learned about scatter plots and have made some and just kind of looked around, learned a little bit of the vocabulary, it's time to begin to know how to describe them and interpret them. I have 4 words up here on this screen. Anytime they're describing scatter plots, we should always look at these 4 characteristics of them to describe them. What is the direction of the relationship? We call it correlation. How do these 2 quantitative variables correlate, or relationship? What is the relationship like? What's the direction of it? What is the form of it? And what about any unusual observations? In the scatter plot help video, we went over that in detail. How strong is that relationship? So this help video is going to talk about the direction, form, and strength, the other 3 of these characteristics that we want to talk about, descriptions. So let's start with form. Okay. Typically, we're going to talk about these 3 types of forms at our level here for this course. And the form will either be linear, and that's where you will see that cluster cloud of points, basically hovering around a straight line that will either be sloping up or down. Or we would have a nonlinear form. That's where you will see a pattern, but it's not a straight line pattern. It could be a curve or some other shape like a hammer or something else that is some pattern, but it's just not a straight line. And then finally, there's this no form at all or no relationship at all between those 2 variables can be seen. I always tell my students it looks like a sneeze pattern. Someone went achoo onto the paper. Is really no form whatsoever. And what this really means is as I move along that x-axis, I cannot really see any predictable change in the y. There's just doesn't seem to be any relationship there. So what about the direction that you'll talk about? Of course, students are going to practice all this. I'm just hitting the highlights for you. Well, of course, direction is only going to apply if it is linear. The linear form will be either positive or negative, just like your slope is positive or negative. It's either going to slope up from left to right, so that means as x increases, y increases, or it'll slope down from left to right. As x increases, y decreases. You have either a negative or a positive direction here. But of course, we always want to interpret this in context. So if we were thinking about our animals, which these particular graphs are not from, but something like this, the older the animal, the more it tends to weigh, just like joy, or the humans, right? The older the animal is, the more it tends to weigh. That would be a positive slope, positive direction. Or a negative example would be the more video games I play, the lower my test score at school the next day because I didn't study. Something like that. They will practice the direction of some scatter plots. And then the third descriptor is strength. Of course, if I don't have any form at all, this doesn't apply because if there's no form, then there's no strength to it. Okay? But the strength, this is where we're going to have a quantifier here in just a minute, but it's either very strong or it's going to be weak. There's going to be a number here applied to this that we can do so that we can talk about in between points here. Strong means if I see that invisible line going through my linear relationship here, or if it's a non-linear relationship, I can see an invisible form there too, then how strong is it to that form, linear or non-linear? That means they're tightly clustered to it. So as I could see in this first example, yeah, I could see that's real tightly to that particular straight line going through there. Whereas on the right side, they're really loosely, scattered about it. I could kind of see a line dropping negatively through there, but it's very, very loose. What you know about if it's a strong relationship then is if I know my x value, I could feel pretty confident in predicting. I get a good idea to predict what the y value could be. It's not perfect, but I would feel more confident predicting. If it's a weak situation like on the right side, that tells us a little bit less about what it could be, and I might be less confident to predict. We want to get a little bit more technical with that strength because you look at all these scatter plots are so different, and we're going to use this letter called R. And R is called the correlation coefficient because it's going to give us a quantifier for that strength. R here is a number that will run from -1 to 1. That positive and negative tells us that direction. If it's negative, it's the negative slope of the line, positive slope, then it's positive direction. Okay? And an R value of 0 would mean there's no correlation at all. That's that sneeze pattern. It's just nothing. There's no form, no correlation. Basically, there's just nothing going on there. The closer we get to 1 and at 1, that's a perfect straight line. Okay? And by the way, R only has something to do with straight linear form. We're only talking about linear forms here when we're talking about using R. We have a -1 would be a perfect negative straight line. A positive one would be a perfect positive straight line. And then in between, we give some clarifiers there. So the students basically, you get some, what's considered strong, moderate. You can see those numbers that we give as guidelines. But it kind of depends on the context. You know, if you're doing a study that where depends on someone's life, like in a medical study or something, you may want your R to be a little higher because life and death situations, you want to have a stronger correlation before you depend on your predictions, right? These cutoffs are just suggestions, and it also depends on what your context is. So making sure that we take that into consideration. There is a little game in your lesson plan called Guess the Correlation, and it's really good for the kids to play it. Just play a few rounds of it, guess the correlation, and they kind of begin to get a feel for what R is, because really sometimes you think that R it's got to be higher than it is to get some strength in there, and it's not really. Like when they see the dots scattered, they tend to guess lower than it is. So have them play that so they can get a feel for R. So after they've done some correlation, they're going to be ready for doing some linear regression next and going further in their analysis. I would like to sneak in an additional but very important aspect of our Bootstrap curriculum. Students have learned about or will learn about linear relationships in their middle school, Algebra 1, Integrated 1 math classes. But you saw us talk about nonlinear form here in this correlation lesson. And so they might begin to say, well, wonder what functions model those nonlinear relationships. Well, you see Bootstrap here offers lessons that will blend data science with those nonlinear forms. And that's a bigger foundation of our Algebra 2 curriculum or Integrated 3 curriculum. But you can see here we have the quadratic, and that linear just doesn't quite model that, but they can explore. You've got quadratic, exponential, and logarithmic models that are there, and they can explore those in the part of the data science curriculum. So what's really cool is that if you're a data science teacher, you can now integrate some Algebra 2 content into your course. And if you're an Algebra 2 teacher or Integrated 3 teacher, you can integrate some data science into your course. And Bootstrap allows you to do just that.